Hello geometry students, welcome to our chapter 1 review packet questions. I'm going to go through all the questions that you'll see in your packet. Please try the problems yourself first. I urge you to do that so that you get the best practice possible. Just use this as a guide to help you with the ones you need help on, or if you try them all first and then you just want to see how you did and I get my explanation on things. So try them all yourself first and then go from there to use this how you see fit. Let me draw this in a little better. This is supposed to be an A and a B right there. So for this one we're going to use, or for these two we're going to use these pictures, or this picture right here for the answer to these two. So number one, what is another name for line B? So here's line B. It's got points D, B, and F on that line. So any of those 2 points would work. I'm looking at the choices here. B, C, that would be this line, the one that kind of goes through the plane. And then another name for B is not going to be B, it's the same thing. N is the name of the plane and not a line. So this one clearly would have to be choice B, DF. Number 2, name the intersection of lines A and B. Well, where did those lines cross? Here's A, here's B. They're crossing right here at this particular point, which is point B. So that one is also B. Moving on to number 3. You're asked how many planes contain points B, C, and A. So which one has all 3 of those points? So I've got A right here, I've got B right here, I've got C right here. It looks to me like there's only one plane that has all 3 of those points. It would be this kind of back left plane, you could say right there. This plane would contain all 3 of those points. Since these are non-collinear points, that's the only plane that would contain those 3 points. So it looks like this one, number 3, should just be 1. And then name 4 points that are coplanar. So let me get rid of what I did there. So 4 points that are coplanar, G, D, let's see if this one's right, G, D, L, and B. Are those all on the same plane? No, I think that's pretty clear that G is not on the same plane as B, L, and D over there. How about our next option? So we've got C, K, A, and G. It looks like A, K, and G are all on this line, and then all 4 of those points are on this plane, the front of this triangular prism right here. So 4 points that are coplanar, that's going to work right there. Choice B for that one. L, A, C, and G, just to check those and make sure they're not right. L, A, C, and G are right here, but L's not on that same plane. And K, B, D, and L, you've got K right here, B, D, and L. So B, D, and L are on the same plane, but K isn't on the same plane as those ones. So it looks like we definitely have the right thing there. So I'll write that in right here. This is A, and this was B. Moving on to number 5 then. In the figure, ray GK bisects FGH. So if I know that's true, I'm going to put this right on the picture right away. Same number of arc marks on both of those angles, since this ray, in other words, cuts that angle in half. So now if this is true, if the measure of FGK is 7V minus 1, so here is FGK, they're saying this is 7V minus 1, and the measure of KGH, connect the dots, K to G to H, would draw that angle out. That's 6V plus 3 right there. Trying to find X. Well, if I know this is congruent to this, I know that then would have to be equal to that in measure. So 7V minus 1 we could say is equal to 6V plus 3. From there, it's just a pretty basic algebra problem. Subtract 6V, I think would be the best way to start. Add 1 to both sides. The V's are gone here, the integers are gone there. You're left with your answer of V equals 4. And so we're trying to find X. What is X now? I need to take this, so not my final answer there, but that's important. I'm needing to take this and plug it back into 7V minus 1 and see what I get. So 7 times 4 minus 1, that's going to be 28 minus 1, which is going to equal 27. So notice, trying to trick you here a little bit, v equals 4. 4 was an answer choice, but that's not finding what it asks you to find. So finding x, we got to plug it back in. So be careful, something like that might happen on the test. Let's check out number 6 now in the figure, and number 7 in the figure use the figure, to find the angles. And alright, got lots of different points in there. Name a pair of obtuse adjacent angles. So we have 4 choices here. Let's figure out which one of these 4 choices fits that description, a pair of obtuse adjacent angles. So I'm going to get out highlighter colors on this one. I'm going to highlight away here. Oh, that's too big. Much too big. That's better. So KQG, let me draw that out. K to Q to G, and H to Q to M. H to Q to M. Are those 2 obtuse angles? Yes, I would definitely say so. Are they adjacent though? Do they share a common side? No, they don't share a common side, so not that one. Let's check out this one, GQL. Here's GQL. And LQJ. So LQ and J. So it would be this angle right here and this angle right here. Are they obtuse? I would say this one, it's clear looking at the picture that that's a little bigger than 90. This one definitely is bigger than 90. So they're both obtuse, and they have this side right here. I'll put that in blue. They have this side in common. So they have this adjacent side. They are adjacent angles then. So it looks like choice B on this one is the correct choice. Let me get rid of all that stuff there. But choice B, that's going to be the right choice here. GQL, GQI, sorry, just to check that GQI. That's not even obtuse, so we don't have to check that. And then choice D, HQG, H to Q to G, also not obtuse there. So those ones definitely wouldn't work. We could eliminate those. Name a linear pair. Alright, let me get out highlighter colors here again. KQG. Where we go? There we go. KQG. Right there. Right there. So we'll draw that angle. Is that a linear pair with H, Q, and M? If I draw that out, that'd be that angle. Is that going to be a linear pair? No. How about GQL? Be that one, and LQJ. LQJ would be right here. So is that a linear pair? They're adjacent, but they're not a linear pair. So it looks like we have the same choices here as we had before, but clearly not that going to form a linear pair, not that pair. GQI, that's this one, and IQM, that's this one. You put those together, do you have a linear pair? Do they form a straight line together? And are they adjacent? It's yes to both of those questions. So that, in fact, is a linear pair. It looks like that should be our answer. Let's just check D and make sure that one doesn't work. So we have LQG. LQG would be this one. And KQM would be this one right here. So this angle, they're not adjacent. They do not have a common side. So not a linear pair in that case. So choice C, that was the right choice. I'll write that over here as well. Moving on to some short answer stuff now. Instead of multiple choice, use the number line to find the measure. So MK, what's the distance from M to K? I always start with the rightmost point and just do that one minus that one. That way I don't have to use absolute value, but you could use absolute value if you wanted to. If you wanted to do left one minus right one, you would have to use absolute value. But MK is going to be, you got 1 and you've got -3 right there. So 1 minus -3 is the distance between those 2 points. That would be 1 plus 3, which would equal 4. You could also just count the jumps, count the spaces, but that could get pretty tedious if you have a long ways to go. So just do the right one minus the left one. You'll get your answer right away. So that'd be 4, and this other one, HQ, headquarters, is going to be, well, where's H? Here's H, and here's Q. So I've got 5, and I've got -5. So this would be 5 minus -5. I could think of it like that. That's 5 plus 5, which is 10. So the answer for that one should be 10. And I just realized, going back here, I forgot to put the answer choice back there. So just so that's clear, 27, that was choice B right there. Okay, number 10. Draw and label each figure described. So let's draw an example of something like this. I'm just going to draw this freehand. If you wanted to use a ruler or a straight edge, that would be a good idea as well. I actually have some straight line tools, so I'll just use those tools while I do this one. So NFL, go Lions or Broncos. Seeing I live in Colorado, I'm kind of obligated to root for the Broncos, right? But I've kind of always liked them anyways. But yes, the Lions, being a Michigander originally, that's where my heart really is. Go Lions. Come on guys. It's been so long since we've had success in Detroit. FM bisects NFL. So let's label some points on here. If FM is the bisector of that, this could be F and this could be M. And if that's bisecting this angle NFL, I could have N up here, or I could have it down here. If I have it here, I would have to have L over here. I could switch L and N around, that would be okay as well. And to show that it's a bisector, we should show that these two angles are equal to each other, congruent to each other, in other words. Number 11, line L intersects plane H at X. So it's intersecting, it's not on the plane, but it's actually kind of going through that plane. So let's draw a plane out here. And so if this is plane H, finish that off there. I'll do this part freehand. So this, pretend it's like an arrow shooting through the plane, and it intersects at X. So that point where it comes through that plane would have to be X, and it's called plane H, using script capital letters for that. So there's H. That's a horrible looking H, but that is plane H right there. Lines A, B, and C are coplanar, but do not intersect. So let's draw another plane. And if they're coplanar, they all have to lie on the same plane. But if they don't intersect, that means they would have to be parallel. So let's say this is line A. I'll go with green. This is line B. This is a freehand sketch. So we're imagining that these lines are actually parallel. Oh, why not orange? This will be C. So these lines don't intersect. They're parallel, but they are on that same plane. They all lie on that same plane. Number 13. Finding YZ. YZ would be this minus this. That would be what's left over for there. So you have 6 minus 4 1/4. And it looks like that would be 1 3/4. And it's inches, so don't forget your units. If there's units given, I expect to see those. Find the value of the variable and GH. If H is between G and I, GI equals 5B plus 1, HI equals 4B minus 5, and HI also equals 7, it looks like. So let's draw a picture of that situation. So let's say that's our, there we go, that's our segment in question. H is between G and I, so G and I would be my endpoints. H is in between there, that means it has to be collinear. I don't know if it's exactly halfway in the middle. I'll kind of draw it almost like that, but note that this isn't necessarily the same length as that. And GI says is 5b plus 1. So the whole length then is 5b plus 1. HI is 4b minus 5. And HI is also equal to 7. So I'll put that underneath. So I can think of HI as 7. I can think of HI as 4b minus 5. If that's the case, if HI equals both of those things, then this must equal that. 4b minus 5 has to equal 7. Solving that for x is going to leave me with, I would have 4b is equal to 12. Divide both sides by 4. And you've got b equals 3. From there, I can then plug in 3 in for b right there. So if this is true, I'm going to plug that in for b and get 5 times 3 plus 1 would be, that's what GH is, or that's what GI is, excuse me. And so that would be 15 plus 1, which equals 16. And we know that GH and HI together would have to add to that whole value, 16. So that means 16 minus 7 right there would have to be what GH is. So I can say that GH then is 16 minus 7, and that equals 9. So that was what I was trying to find up here, find the value of the variable. So let me box that in. That was my variable. That's part of the answer. And then this is the other part of my answer. So we found the value of the variable and GH based on that. Continuing with number 15 and 16, you can use the distance formula. I'm going to use a Pythagorean theorem because it's really the same idea. It's the same concept in disguise. If you want to use the distance formula and try that way instead, you should get the same answer in the end. So number 15, I'm going to make a little right triangle here. If you wanted to do the distance formula, that's this, the y2 minus y1 squared plus x2 minus x1 squared. It's the square root of all that. So it's the difference in the y's squared plus the difference in the x's squared, the square root of that whole expression. So you could do that. If you want to use that instead, go ahead, be my guest. I'm going to use the Pythagorean theorem instead. So I'm going from here to here. That's a difference of 5 in those y values, from 0 to 5. And then from here 2 to 4, that's a difference of 2 there. So here I have 2 squared plus 5 squared equals this length that I'm trying to figure out, the distance between w and t, so wt squared. This would be 4 plus 25 would be wt squared, and that means 29 equals wt squared. And then from there, I can take the square root of both sides to get my answer. Square roots and squares will cancel right there. So the square root of 29 equals wt. That's already in simplified radical form. There's nothing we can pull out of that square root to make it any different. If you were to plug that into a calculator, you would get a little more than 5, almost 5.5. It looks like with that. But leave it as an exact answer unless you're told otherwise. And just did the calculator work on that. If you were to get a decimal, it would be about 5.4 is WT. But best to leave it as an exact answer unless you're told otherwise. On this one over here, we can form a right triangle right here. And I could have went down in this way instead. That's fine, either way. How long is this length? How long is that leg? It looks like 3. And then this one is 1, 2, 3, 4, 5 right there. So in this case, we have 3 squared plus 5 squared equals WT squared. So you have 9 plus 25 equals WT squared. That's 34 equals WT squared. And you take the square root of both sides, just like in the other one. Square roots squares will cancel. And you're left with the square root of 34 equals WT. And if you get that as a decimal, that's approximately 5.8. So this is better, unless you're told to round, use the exact answer, but that is an approximation there. Number 16, find the coordinates of the midpoints of a segment having the given endpoints. So let's draw a graph of this. I've got my grid on here to make it easy. I always think it's good to visualize what's going on in geometry, especially. And let's do horizontal like that. We'll assume that everything is just going up by 1, so I won't put the scale on there. Just assume that that's the case. Let's draw these in. So you have -6, 1, 2, 3, 4, 5, 6, and +4, 1, 2, 3, 4. So there's -6, 4. That's point Q. And then -7, 1. So back 7, up 1 would be right here. That's point R. Now I don't have to draw the picture to figure this one out, but I think it's helpful to see what's going on visually. And so this, I'm saying I'm trying to find the midpoint of that segment. So if I connect those, the midpoint to me looks like it's going to be right about there. The midpoint formula, we should definitely know what that is. That is, you're adding the x values together, dividing that by 2, and adding the y values together, and dividing that by 2. The average of the x values and the average of the y values, in other words. So if we use the formula, we label some points here. This would be x1, y1. This would be x2, y2 right there. Plug those values in. So add up the x values. You have -6 plus -7. That over 2. And you've got 4 plus 1. That over 2. This is -13 over 2. And 5 over 2. You could leave it like that, or you could say that's -6.5 and 2.5. That probably makes more sense in the context of this problem. To use a mixed number or a decimal would also be good as well. And so if we look at our picture, that should make sense based on what we see there. 6.5, -6.5, and then up 2.5, that would be right about there. And that certainly looks like the midpoint of that segment. So visually, we can see that it matches up with what we got algebraically. Let's take a look at numbers 18 through 20 now. It says in the figure, ray KJ and ray KL are opposite rays. Okay, I can see that. They form this straight line together. Angle 1 is congruent to angle 2. I'm going to draw that in my picture. So those two are the same measure, have the same measure, and KM bisects NKL. So this angle right here getting bisected. I'm going to put 2 marks here, and the same thing over here, 2 marks over here. So this is when 3 is congruent to 4, and 1 is congruent to 2, excuse me, based on that information. So if the measure of JKP equals 4x plus 15, and the measure of 2 equals 6x minus 5, what is the measure of JKN? Let's write that information in there. I'll use red to write this extra information in there. So JKP, that's this angle right here, if I draw that out. This is 4x plus 15. And the measure of angle 2, that's the same as PKN right there. That's 6x minus 5. So with that information, and knowing that this is this angle is congruent to this angle, I can say that this then must equal this right there. So this has to be true for number 18. 4x plus 15 has to equal 6x minus 5. So from there, you could subtract 4x from both sides. You could add 5 to both sides. That would cancel there, that would cancel there. You're left with 20 equals 2x, divide by 2, and you got 10 equals x. We're trying to find, though, the measure of JKN, so we can use this information, plug it back into there. To find JKN, we would be adding this to this. So really, we could just find one of those and multiply it by 2, but it might be best to at least plug it back in here. This would be 4 times 10 is 40 plus 15 is 55. So this becomes 55 right there. And then this one, 6 times 10 is 60 minus 5. That's also 55 if we plug in 10 for x. So the measure of JKN is going to be that one plus that one. So JKN, that's 55 plus 55, which would be 110 degrees right there. So this was coming from 4 times 10 plus 15. This was coming from 6 times 10 minus 5. I'll use green for this next one. So if the measure of LKN, now LKN is the big angle, the bigger one, 4 and 3 together here. So I'm saying from here all the way to here, this angle is 22A minus 11. And the measure of angle 4, so just this one, is 12A minus 8. What is the measure of angle 3? Well, I know that 3 and 4 have to be the same, so if I knew what 4 was, then I'd know what 3 was as well. I know that this angle, the whole thing, has to be twice as big as angle 4. So based on that, I could set up another equation. I could say that 22A minus 11, that would have to be the same as 2 times this one. 2 times 12A minus 8. And let's solve that now for A. So I've got, going to distribute that 2. Got 24A minus 16. Subtract 22A from both sides. That moves the A's to the right, move the integers to the left then. And it looks like you'll have 5 equals 2A. You divide both sides by 2. You'd have 2.5 is equal to A. So that looks like an important bit of information. However, that doesn't tell me what angle 3 is yet. So I'm going to take this now, plug in A right here, and see what angle 4 is. Once I know what angle 4 is, I automatically know what angle 3 is. They have to be the same based on the fact that that was a bisector for the big angle right there. So this then would imply, that would mean that you've got 12 times 2.5 minus 8. That's going to be the measure of angle 4. 12 times 2.5 looks like that's 30, and 30 minus 8 would be 22. So this one we should have 22 degrees is equal to the measure of angle 4. And I'll use orange for number 20. So if the measure of JKM, I'm going to erase some of this stuff here. If you are going to miss that, you can always rewind the video. That's a nice thing there. I'm going to leave the blue though, because that's true in every single one of these based on the initial information. So just erasing the red and the green stuff. There we go. And now in orange, if the measure of JKM, so that's this angle right here, that's 1, 2, and 3 all together. Why don't I get my highlighter out for that? So JKM, talking about this angle right there. If that's 4R plus 7, so all the way from here to here, saying is 4R plus 7, 1, 2, and 3 added together. And the measure of angle 4 is R minus 2. So this one, R minus 2. What's the measure of angle 4? What is that in terms of an actual numeric value? So I can look at this and this. Since these two form a linear pair together, this angle, the highlighted angle, and then angle 4, they form that straight line together, I could say that this one and this one added together must equal 180. So I can say that plus r minus 2 has to equal 180. I could put those in parentheses if I wanted to. I don't really need those parentheses there, but that's okay if you drew them in there. You'd have, combining like terms, 5r plus 5 equals 180. Subtract 5 from both sides. And that's number 20, by the way. Meant to write that down earlier. Subtract 5 from both sides, and then I'd give you 175, divide by 5. And we've got what r is, so r looks like it's going to equal, r is going to equal, that would be 35 right there. So take that, that's not your final answer. It asks for what's the measure of angle 4. It should be pretty easy though from there. Take 45 or 35, plug it in right there. That means that you're going to have 35 minus 2 for the measure of angle 4, which would be 33 degrees. So that right there is your final answer for number 20. Let's check out 21 and 22. These kind of go together. 21 says the measures of two complementary angles. So right there, that means they add to 90. Remember, C comes before S in the alphabet, just like 90 comes before 180 on the number line. So they match up like that. They go in order. So they are 7y minus 3 and 3y plus 3. That means they're complementary. They're supposed to add together to equal 90. So 90 has to equal this plus this. So let's write that out a little nicer. It would look like this, plus 3y plus 3. Could use parentheses if you wanted to. You don't really need them. Combine like terms, 10y, the plus 3 minus 3, they'll cancel each other out. Divide by 10. That means that y equals 9. Important information there, but not our final answer. It says find the measures of the angles. So now I'm going to plug those back in. So one of the angles is going to be 7 times 9 minus 3, and that would equal 63 minus 3, which equals 60 degrees. The other one better be 30, otherwise I did something wrong, because they're supposed to add up to 90 together. So that's one angle. The other angle would be, plug it in right there, 3 times 9 minus 3, plus 3. That is equal to 27 plus 3, and I got it. That equals 30. Looks like I got the right thing. 22, two angles are supplementary now. And one of the angles measures 36 degrees less than the other. That means if one was x, the other one would have to be 36 degrees less than that. So x minus 36. If it helps you to draw a picture could look like this. We could have x and x minus 36. The smaller one could be like that, and the bigger one could be like that. If they're supplementary, they could form a linear pair. So that's a possible way to depict a situation like that. Up here, if you wanted to draw a picture, since they're complementary, they could form a right angle together. One of them, we didn't necessarily know which one was bigger at first looking at that, but it looks like this would be a valid setup, something like this to start. That's 90 degrees altogether there. So from there, based on that information, this is adding to 180. We can say 180 equals this one plus this one right here plus this one right here. So let's write that equation out a little nicer. From there, you can combine like terms. You can add 36 to both sides. That'll get you 216. Divide by 2. That gets you 108 for x. Important information again, but not a final answer. One of the angles does in fact equal x. So one angle you could say is 108 degrees. And the other one, that's 180 minus 108. So it's, or not minus, I'm sorry. Take that back. It is something minus something. It's 108 minus 36. So it's our x value minus 36. And it looks like that should equal, yes it does, it equals 72. So take this one and this one, add them together, it should be 180, and in fact it is. Number 23. Name each polygon by its number of sides, then classify as convex or concave, and regular or irregular. So this one, I've got 1, 2, 3, 4 sides here. That's a quadrilateral then. Is it convex or concave? Well, there's no caving in parts. I can take any segment I want on the, pick any 2 points I want on the inside, draw a segment. It'll never fall outside of the shape. That's another way to think about convex and concave. So this one, no caving in parts. It's going to be quadrilateral, convex. And is it regular or irregular? If it was regular, all the angles and sides would have to be the same. Clearly that's not the case here. So this is irregular. So that is for that one, 24. Looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides right there. So our fancy name for that was a dodecagon. 12-sided polygon. Is this convex or concave? Well, we do have caving in parts here. If you picked any 2 points in there, it is possible to pick 2 points, draw a segment where part of that segment goes outside the shape. That's a way to think about what's convex or concave. But we do have these caving in parts. You can think of it like that too. So concave. And is it regular or irregular? Again, regular has to be all same sides, all equal sides and all equal angles. Not the case here either. So irregular is the proper choice for that last part of the question. Let's keep moving. 25 through 28, we're supposed to find the length of each side of the polygon for the given perimeter. On this one, the perimeter is 108. And it looks like we have a rectangle here. So this and this would have to be the same, and this one would have to be the same. They're labeled as such as well right here. We got 2 congruent sides there and there, 2 congruent sides here and here. So I could say that the perimeter, 108 in this case, would be those 4 added together. But really we have 2 of these and we have 2 of these. So I could just say it's 2 times 2x minus 5 plus 2 times 4x minus 13. So let's distribute. That'd be 4x minus 10. This would be 8x minus 26. And then combine like terms. You've got 12x minus 36. Add 36 to both sides. You would have 144 equals 12x. And then from there, divide both sides by 12. You've got x equals 12. That means this side would have to be 4 times 12 minus 13. That'd be 48 minus 13, which would be 35. And that would make this 35 as well. So that's important information. That's a final answer. A part of a final answer. This would be 2 times 12 minus 5, 24 minus 5, in other words. That is 19 right here and right here. If you add all those up together, you should get 108. This would be 54 plus another 54 with these two together. That does equal 108. For this one, the perimeter is 49 units. Find the length of each side. So this and this are now congruent. So that means you've got another 2n plus 2 over here. But really, I can just write that. Think of it like I did over here. I've got 2 of those. So I've got 2 times 2n plus 2. And then I've got just 1 of these, so plus 2n minus 3. Work that algebra problem out. We've got 4n plus 4 if we distribute. Combine like terms. You've got 6n plus 1. Subtract 1 from both sides. You've got 48 equals 6n. Divide by 6 on both sides. You've got n is 8. So from there, plug in the values. 2 times 8 minus 3 would be 13. And then over here, you've got 2 times 8 plus 2. That would be 18. So this is 18. That means this side also has to be 18 since they had the same number of tick marks. That's 36 plus 13. That makes 49 like it should. On this one, you've got 72 units for the perimeter, given all these different expressions on this one. So it looks like we just have to add those 4 expressions together and set it equal to 72. So r minus 4 plus 2r plus 9 plus r minus 8 plus 2r minus 3. Combine like terms, I've got r, 2r, r, and 2r. That's 6 r's altogether. Negative 4 plus 9 is 5. Minus 8 would be negative 3. Minus 3 would be negative 6. Add 6 to both sides. And then divide that by 6. And it looks like that means you would have r is 13. Take that value, plug it in. 13 minus 8 is 5 on this side. Over here, 2 times 13 minus 3 would be 23. Over here, you'd have 13 minus 4, which would be 9. And right here, you'd have 2 times 13 plus 9 would be 26 plus 9, which is 35. If you add all this together, let's see, we'd have 44 there. We'd have 28 here. 28 plus 44 would be 72, like it should be. And then right here, actually the easiest one of this bunch, saved for last. Since these are all the same, you can just take your perimeter, which is 54, and divide it by the number of sides. So 54 divided by 6. There are 6 sides. That means each side length would be 9 miles in this case. So really we should say miles here. That was my units given right here. This one just said units, this one said units, so I could leave units off. But this one would be miles, and this one likewise would be miles. So 9 miles, all 6 sides are going to be 9 miles over here. Getting close to the end here, name each polygon by its number of sides. Let's count them up. This is 1, 2, 3, 4, 5. We should know 5 is a pentagon, so this one should be pentagon. On here you've got 1, 2, 3, 4, 5, 6, 7, 8, 9. A 9-sided polygon is called a nonagon. And finally, with this bunch, this would be 5-sided shape as well, so it looks like another pentagon in this case. And finally, number 32. Find the perimeter of the pentagon ABCDE with vertices that you see there. So let's make a picture of this to make it easier. Let me get out my straight line tools here. So we're going, looks like 7 is our biggest value, so I'll make sure I have 7 going in each direction at least, and then I'll be good to go. Alright, so that's a little long there. Let me pull that in. Grab it. There we go. So let's see if that's big enough to encompass all of those points. Let's label those points. So we've got negative 6, 2. 1, 2, 3, 4, 5, 6 back up to. There's point A. Negative 6, 2. Point B is negative 4 and then 7. So 1, 2, 3, 4, 5, 6, 7. Looks like there then would be point B, negative 4, 7. Point C at 0, 4. So here's 0, up 1, 2, 3, 4. There is C. And D is right there at the origin, 0, 0. So we're trying to find the perimeter of this shape. Let me erase this and just write that underneath. so that I can connect these with some segments. So connecting the dots there, I want to use red. There we go. We are trying to find, basically we need to find the length of each side and then add that all together. So this one, I think here, I'll go green now to label those sides. This one's pretty easy to see. You're just going up from 0 to 4. From that y value to that y value, that's going to be 4 right there. On this one, I'm going to use Pythagorean theorem. If you like distance formula, you could use that to figure this out as well. But for this particular length, this would be 3 for one of the legs, and then 1, 2, 3, 4 for the other leg. If you do 3 squared plus 4 squared equals BC squared, that will give you a correct value for BC. Leg squared plus leg squared equals hypotenuse squared. So you got 9 plus 16. That's 25. Take the square root of both sides. Square roots and squares cancel. You've got 5 equals BC. So this one worked out pretty nice. That's going to be this value right there. I'll continue to color code some things. So I'll go purple now. Make a little triangle here. This one's going to be 2 going in that direction, and then 1, 2, 3, 4, 5 going in that direction. So you've got 2 squared plus 5 squared equals AB squared. That's 4 plus 25 equals AB squared. So that's the square root of 29 after you take the square root of both sides. And right now I'm going to leave it as an exact value, and I'll approximate that at the end. Finally, in orange, I'll go down here, figuring out what's the length of AD based on this right triangle. So this is going to be 2 right here, and then going from -6 to 0, that's going to be a jump of 6 right there. So you've got 2 squared plus 6 squared would equal AD squared. That's 4 plus 36 equals AD squared. This is 40 equals AD squared. Square root of both sides. You'll have square root of 40 equals AD. Now you can rewrite this as 4 times 10. I do that because 4 is a perfect square. So if there's a perfect square that's a factor of that number on the inside, take it out and leave the rest in there. So this is 2 times the square root of 10. That's simplified radical form right there. So if we put that all together, I'll go back to blue. My perimeter of this shape is going to be those things added together. So this was 5 right there. This length was the square root of 29. And then this one was 2 square root of 10. So we're adding these 4 values together. This one, this one, this one, and this one. So we have 5 plus 4 plus 2 radical 10 plus square root of 29. So we can combine these two things together. We could say that that is an exact answer, and then let me check the approximate answer. Oh man, and I just noticed a big mistake I made. This is supposed to be a pentagon, so I can fix this, but E is supposed to be at -4, 3, so it's kind of a big deal. Gonna have to erase that one and erase some other things here. So if you were yelling at me, "What are you doing, Mr. Wagner? No, don't do that," that would be a good thing. I need to just get rid of this. So the orange stuff, yeah, this is gonna have to go away, and we'll change that around. Hey, that's why I write in something that I can erase. It does not give you permission to use erasable pencil, or pen, I mean. It does. You should be using erasable pencil. But But let me draw in that last point. So the work we did here in green and purple, that's still valid. I do need to finish erasing this stuff. And let's put in, that's why I got to read the whole question. I was getting too excited. We're getting close to the end there. So D is there, but E is -4 and +3. So right there. So the vertices, we're connecting them in that order. If they're written in order, we connect them in that order. A, B, C, D. This is going to be E right here at -4, 3. So connect that. Connect that here and connect that there. So I still need to figure out what's the length of this one and then what's the length of that one. But all my other information is valid. So let's figure that out. So back to orange. Select it. There we go. So this is going to be 2 and this is going to be 1 right there. So in orange, this length, AE squared, the hypotenuse squared, would be 1 squared plus 2 squared. And that means AE squared is the square root of 1 plus 4. Or AE is 1 plus 4. And then that'd be 5. We take the square root of both sides then. Square roots and square roots cancel. AE would equal the square root of 5. That's an important piece of information, but not to our final answer yet. Let's do finally, what color haven't I used yet? I'm going to have to come up with a new color. Yellow is not going to show up very well. I'll use blue. No, I'll use something else. Why don't I go back to green? Yeah, that'll work. So back to green. This one, I've got 3. I know there is a way to pick more colors. I just forget how to do that right now. So 3, then 1, 2, 3, 4. And so this would be another 3 squared plus 4 squared. How convenient, actually, that this was in green, because it's exactly the same as what I did right there. So we could say this also equals DE. Don't need to do the math again on that because I already did it up here. So you'd have another 5 right there. So I'll highlight these things now. Putting this, there we go. Putting this together with this value, and then that was the square root of 5. So that one, I'll write that in a second. This was a square root of 5 right there. So if I connect A to B to C to D to E, I'm adding those 5 values together. So all my highlighted values there, I'm going to put those all together now. And why don't I write them in that order, just so I think it'll make more sense that way. So you got the perimeter is going from here to there is a square root of 29, from A to B. From B to C is 5. From C to D is 4. From D to E is another 5. And then from E to A is the square root of 5. So I can combine the integers together, but I would have to leave square root of 29 and square root of 5 separate. Those are not like terms in a sense. We could say a square root of 29 plus a square root of 5. It would both have to be the same number under the radical for that to work, for them to be combined together. So an exact answer would look like this. This would be 14. So you could say that this is your exact answer. There's no units given, so you don't have to write units at the end. If you were to approximate that, let me check and see what that equals. And that is approximately 21.6. And if you wanted to write the word units, you could. But if there's no units actually given, you can just leave that out. So from there, this does not mean that something that wasn't here can't be on the test. Anything we covered in class in the notes, something like that, that could be valid test material. But if you know how to do the stuff on this review sheet, you should be pretty good to go. I think you should be very confident in your ability to do well on this test. I hope you found that helpful. I hope you watched what you needed to and actually tried all these problems yourself first. It really is not going to help you all that much, I don't think, unless you do that first. But if you just watched it just to catch my advice on problems like these, that's great too. Use it how you need it. Review it as you need it. Go back and pause and rewind as necessary. Hope you find it helpful. Feel free to leave a comment, to like the video, get the word out there to help other students if they need it as well. Hope you have a great day, and I'll catch you later, either in class or here on YouTube. See you later.